Hello, my name is Ethan Wilson, and my cognitive revolution presentation is over artificial intelligence. Artificial intelligence can be traced back to the early 1950s. One of the first Americans who worked on artificial intelligence was Norbert Wiener, who made observations upon the feedback theory. He theorized that intelligent behavior was a result of feedback mechanisms, which could be simulated by machines. So this can be considered part of the beginnings of artificial intelligence, because he was saying that by reacting to what is around us, that it's part of what our intelligent behavior is. So intelligent behavior can be simulated by machines since they can react to what's around them. In 1955, what is considered the first AI program was created. It was called the Logic Theorist and was created by Newell and Simon. They used a tree method where a problem had many branches, and the computer or the machine would have to pick which branch to follow in order to solve the problem. They had to pick the best one. John McCarthy, who's considered the father of AI, also invited a number of researchers to what he called the Dartmouth Summer Research Project on Artificial Intelligence. This is where the name artificial intelligence for the field came from. Ever since then, that's what the field has been called. He also invented the LISP system, which is a computer language that is used for almost all artificial intelligence programs. Later, Newell and Simon created a new program called the General Problem Solver, which was capable of solving a variety of common sense problems. And then IBM formed a artificial intelligence research team not long after that. So in the early 1950s to late 1950s was when artificial intelligence really started taking off. In the 70s, expert systems that predicted probabilities were developed. And the vision-based shading for machines was also proposed. It wasn't developed, but it was proposed. Artificial intelligence, what it is basically focused on creating thinking machines. Machines with cognition, cognitive functions. They think, they are intelligent, they can solve problems, and they can store knowledge. So like they use memory, and they can use the memory to solve problems. These systems, they must be able to receive knowledge, think, and store for later use. One of the main tests for this is the Turing test, which the point of the Turing test is for a human judge to be convinced by the machine that the judge is talking to a human. So the judge does not know whether or not he's talking to a machine or a human, but he must be convinced that he is talking to a human in order for the machine to pass the Turing test. But the problem with this is many cleverly programmed machines can have thousands of responses to questions and seem human. But the fact is that whoever programmed them took the time to put in several different responses. There is also other different ideas of how to define intelligence, such as Wiener's feedback theory intelligence, and then there's an AI pioneer by the name of Ray Solomonoff, who related intelligence to the ability to summarize or compress information by detecting patterns. So you had to be able to take everything that you see, pick a pattern out of it, so you compress it into smaller, so you don't have to remember every single little thing down to perfect detail. Because by remembering the compressed pattern, you can pick out all the other details without much effort. There is also a need for artificial intelligence for the machine to be able to solve complex unstructured problems and have the capabilities of abduction, induction, deduction, analogical reasoning, and heuristic search. Abduction is a pattern searching, like you look for the pattern and then it's just hypothesis for why that pattern is. It's basically exploratory data analysis. Induction is discovering new facts and rules from previously known facts. So you already know something, and then because you know that something, you learn something new. Deduction is applying previously known problem-solving applications, so previously known ways of solving things in order to solve a situation that you've never been in before. Analogical reasoning is finding a relationship between what you already know and what is new. A heuristic search is commonly used by humans in order to find faster, though not necessarily more optimal solutions. So basically, heuristic search is just you try and find a faster way to do something, though it might not be better. In the research and evidence, there is things where it's like the Turing test. There's a game or a reward built around that, where you have to try and create more and more better chatbots is what they're called, that can imitate human social interactions in order to convince a human that they're talking to a human and not a machine. These can be seen as though they're intelligent, but because all they can do is talk and reply with whatever they're programmed to reply with, as of yet, they are not truly intelligent. One of the main problems with many machines designed for artificial intelligence is that they are designed for certain tasks, such as playing a specific game, and they can't do much outside of what they are programmed for. A major example of this is IBM's Deep Blue. It is a master at chess, but it cannot perform any other function outside of playing chess. It can beat pretty much anybody at chess, but it can't do anything outside of that. To help with this is the general game playing competition, which encourages for machines to be programmed for many different games. Basically, you can't just program a bunch of different games because you don't know what each game is going to be. So you have to be able to program it to have new sets of rules and understand them, and then find out how to solve the problems through that. For the aspect of intelligence that relates to compressing information and detecting patterns, there's a Human Knowledge Compression Prize, which the object of that is to take a large 100 megabyte extract of Wikipedia and compress it down into ever smaller and smaller data packets to try and get the smallest you can. But AI needs to not only be able to compress, it has to be able to retrieve this information and use it in order to solve a problem. So it can't just pick out a pattern and be like, oh, this is a pattern, and I can compress it into a smaller piece. It has to actually be able to retrieve it and then use it in a problem-solving situation. Another form of artificial intelligence is the expert systems that were developed in 1970. These are very low-based artificial intelligence because they are very focused on very limited areas. They are able to predict and come up with conclusions about problems within their area of expertise, but they cannot do anything outside of that. And they are limited within their area of expertise. What most people see as the major idea of artificial intelligence is robotics or androids. Artificial intelligence researchers who study the theories of androids and robots look into how motor function could influence perception, cognition, language, and social interactions. So it's not just, when it comes to looking into androids and robots, it's not just how they think, it's also how they move. Because how they move is how it can affect how they perceive the world. So it is looking at the relation between the mind and the body. Though there has been a lot of research in artificial intelligence, there is not a lot of public, easy-to-find data on the results. And there has been a large amount of progress, but as a field it is very slowly developing because it started out quick, then it slowed down for several decades, and recently has been coming back with the influx of robots in the market and people wanting to use artificial intelligence for things like smart grids and powering different things and controlling different utilities. It has a large potential to grow in capability to produce machines that are truly intelligent, I believe, and help us with problems that we cannot do, maybe like because we simply cannot handle the amount of information that would come through. So if we can build machines with artificial intelligence that can handle that large amount of information and solve many problems, I believe that could help us in lots of ways. And that is my artificial intelligence presentation. Thank you.